There we go.
Is it just taking forever to load?
Yeah, it usually does. It's great. So I was just thinking that we could do the extension problems because honestly, I looked at the preparation. Have you looked at it?
No, I didn't get a chance to, not for the group meeting, no.
Oh, okay.
Is it pretty simple?
I think so. It's just, I don't know, I only looked at it slightly and then I didn't actually like do them. I just read them and I was like, okay. And then I looked at the key and I was like, oh, that's what it's asking for.
Okay.
Yeah. And so if you'd like, we can go over it, but we don't have to.
No, it's okay.
Okay. Sounds good. We can just do the extension problems and call it good.
Extension problems. There's just two, right?
Yes.
Okay.
I guess we should discuss the things that we should discuss for team discussion. So it says, first, discuss the exponential and logarithmic functions, graphing, etc. I don't know.
I don't really know what it's asking for.
I'm not exactly sure either. I think it's just like what it is, what it looks like on a graph, maybe domain and range, stuff like that. So, exponential, here, I'll draw them. I know exponential looks like that.
Okay. Yeah, that makes sense.
I don't remember what logs look like. So I'll look at it. But domain and range is usually real numbers or exponents or exponential.
Oh, okay.
Right, and logs look like that.
So instead of going up like this, they're going like that.
Mm-hmm.
Okay.
Yep, and their range or their domain is that it's like 0 to infinity. There can't be a negative input into a log.
Okay.
Yeah. So, anyway, so yeah.
Sorry, I just have so many tabs open. I'm trying to close them so I can actually see what I'm doing.
Yeah, I have a lot of tabs open too.
Okay.
Before setting this up, I was working on humanities homework.
Oh, fun. How's that class going?
It's okay. It's I took Foundations of Humanities in class last semester, and now I'm taking World Foundations 201 this semester online. And I don't know, they both have their differences. The in-class one was really difficult for what I felt like was a 101 class. But this class that I'm in right now is actually pretty simple. You just have to get your work done on time.
That's interesting. I didn't know they let you do that. I thought if you did like the world humanities or whatever, you had to do part 1 and then 2. But you can like mix and match them like that?
I guess.
Okay.
I'm not sure. I haven't actually talked to an academic advisor. I should eventually.
Oh, yeah, it helps.
Yeah, but I haven't yet. I don't know. I'm just like, all right, let's see what I can pick this time. Anyway.
Yeah, hopefully that works.
It's going okay so far. So I'm sure as I start getting to graduating, it might not be as helpful.
Yeah, what's your major?
Computer science.
Okay. Oh yeah, you said that. Okay.
So the second thing is ensure that each team member was able to graph the 3 functions from the preparation assignment. Make sure that the important parts are included in each graph. So that was I know it was like 2 to the x plus 1 minus 3. I think. Like it's 2 and then to the x plus 1 and then back down again minus 3.
Okay.
Yeah.
Interesting.
And I think, yeah. I think she just wants you to understand like the transformations and stuff. I would presume.
So, sorry, how would you graph that? I guess I just don't.
That its parent function is a it's an exponential function, so you know it's going to look something like that.
Okay.
And then with the plus 1 with the exponent, it'll be to the left, I think 1, and then down 3, and that's it, I think.
And that's the starting point for the exponential function.
Yeah.
Would be like -1, -3.
Yep.
Okay.
Sorry, I'm looking at the key too.
And then so, the 2, what does that do?
That's part of the parent function. So you have the base. Parent function, you have the base, and then it's to the x.
Oh, got it. Okay. So it technically is part of it.
Yeah.
Okay.
Now, if it was like to the 2x plus 1, and then it would have a
like it's stretch or whatever.
Yeah, a stretch or shrink. Yeah.
Cool. Sweet.
Yeah. And then, do you see the second one?
The second one. Oh no, sorry. Is this in a different spot or is this?
Oh yeah, it's in the preparation. Like, it says go over the preparation.
Okay.
So it just says be able to graph the 3 functions from the preparation assignment.
Okay, I'll try and get there really quick.
Take time.
From the preparation, is that what you said?
Yes.
It's like y equals -½ x plus 1. Okay.
Mm-hmm.
So that one, it would be like facing down because of the negative.
Mm-hmm.
And then it'd still, I don't think how you draw it. You go down and then you'd go to the right one. So would your starting point be like 0, 1?
Well, okay. In the key, it says that there isn't a left or right, but there is up 1. that makes sense.
Yeah, okay. So why wouldn't you move left or right?
So in like a normal, I guess, like linear equation, when a added value or a subtracted value is with the x, like in a parentheses or something, that's when it's moved left or right.
Oh, got it.
It's kind of like the same concept with exponents. If it's in the exponent with the x, then that's when it moves left or right. But since it's not in this case, it's just an up or down.
So did it go up one?
Yes.
Oh, okay. Cool.
Okay.
So I guess what I don't get is in the graph it shows that it's just passing through like x and y were both 0 instead of like going up one. Do you see that?
I think that might be.
Looks like it's going right through the center.
Yeah. Well, it looks like it's a horizontal asymptote is 1.
Okay.
Yeah, I think that's it. I'm not sure though. It's been a while. Okay. Oh, oops. And then I'm not sure which other function she's talking about.
I don't know. Should we just go on to the next thing then?
We can.
Okay.
Let's do that. Share applications that you know of that use either the exponential or logarithmic function.
Yeah. I don't know.
I know logs are used for something. And if I remember correctly, something to do with calculus, but I'm not sure if that's like an application.
I don't know. I can't really think of anything.
Well, maybe exponents are used for population, I think. Maybe. Hello.
Go ahead, Eduardo.
Hey guys, how are you?
Good.
Doing well.
Sorry, I'm late.
Oh, you're good.
You're fine.
So right now we're just going through the extension problems.
Okay. We have a test this week, don't we?
Yep.
Yes. Have either of you started it?
No. Have you?
I haven't. I'm not sure what number 1 is asking.
Number 1 on the extension.
Yeah. It says, as a team, solve the following equations for something. I would assume X. Discuss the method used for solving and why it works.
What number are we on? Sorry.
Number 1.
Oh,
on
number
the
1.
extension problems. Yep.
Okay. Oh, okay. I was like, what? Where the heck are we?
That's where we are.
Okay. So you guys just started this basically.
Yeah, we talked about some other stuff, but
Okay.
We talked about it like the team discussion thing.
Okay.
Yeah, I'm not sure what to do on this one.
I think I remember how to do it now. So, so if you have one that you're trying to solve for x, like for example, for the first one, you have exponents. So you use logs to reverse it and to get rid of the exponent. Or, well, not get rid of it, but you get rid of the base that has the exponent, so then there isn't an the exponent turns into just a normal linear equation. Does that make any sense?
Yeah. How'd you go about doing that?
So what I did, I'm not sure if this is like correct, but it made sense in my head. I used log base 3 to get rid of the 3. And I think that goes to 1. And so then you're left with x minus 1 equals 2x plus 7, because you have to do it to both sides.
Okay, so then would it be -8?
Yeah, that's what I'm thinking.
Okay, that sounds right.
Well, there's a key. We can check ourselves. What? I'm very confused.
We're trying to find a vertex, right?
I think we're just solving for x.
For the first one?
I thought so, but maybe not.
Well, it says find the vertex and like the intercepts and all that.
Are you looking at the quiz or
I'm
the
looking at
extension problem?
the extension problem. It says write the function f of x equals 3x squared minus 12x plus 1.
Are you in? Maybe I'm in the wrong one. Is it week 5, lesson 3 and 4, group hangout 2?
Oh, no. Hold on. My bad.
Okay, no, you're good. I was like, oh, shoot.
Yeah, I was like, wait, what?
So x equals -y? Is that what you, that doesn't make any sense.
Wait, this is like some other language. What is this?
The heck?
Well, I think it would be helpful if the first sentence of the directions were completed.
So I don't think that's right. X equals -y. Do you think that they?
I think it might be right, but in what context?
Maybe they
think it would
meant
be
to put a
helpful.
-8. I don't know.
It's a bit of a stretch.
Yeah. -y. Is there anywhere else that we could check that? I mean, I guess their answers are probably right, but
we can probably check a graph. So it's 3 to the x minus 1, right?
Mm-hmm.
Okay, this is awkward. It's not letting me like put the minus 1 in with the x. That's so weird.
yeah, I solved the next one the same way that we did it, and I got negative 2/3, which is the answer they have in the key.
So, wait, for the next one, you got the answer that the answer key has?
Yeah, by doing the exact same thing that we did on the first one.
Okay.
So
So, I wonder if it is negative 8. Okay.
yeah, I don't know. Hopefully they don't have anything weird like that, if that's really right. I don't know.
Wait, so how did you do the second one? Because you can't exactly do what we did last time.
You can, because you just take 2 and you take it to the 4th power, which would be 16.
Okay.
And so it'd be like 2 to the 4x.
Okay. Yeah, okay.
You get the same thing?
Yep.
Sweet.
Okay, so for the third one, instead of like for the last one, you would put it all in an exponent, and that's how we cancel out the logs. But since it's a natural log, you use e. And so you have e to the ln x minus 2, and you do it to the other side, and that cancels out the log and the e at the same time.
So basically you're just doing x minus 2 equals 3x plus 11.
I'm sorry, what?
So you would basically just take off the ln.
Yeah. Yeah. Because when you raise it to that e, or when you add that e to raise it to the ln power, I guess, you're actually just canceling it out because it goes to 1.
Okay.
Yeah, and so you're left with the exponents.
So then you'd end up with x equals negative 13 over 2.
Oh, I haven't gotten there far yet.
Oh, okay.
Yeah, that's what I got to. But I'm not sure what it means when it can't.
X equals not one correct solution. What the heck? I have no idea what that means. That's weird.
I don't know either.
So did you guys look at the third one yet, or the last one?
I have, and I feel like there's something else that you have to do that you have to do to it besides just plopping an x and making it raised to that exponent.
So
I guess.
all I did was just take out the log because they're the same, and then you can just solve for x.
How did you take out the log?
Just because they're the same on both sides.
Okay, so they can just cancel out.
I think so.
Okay. Okay, so you got the same answer that the answer key got, right?
Yeah.
Okay. Okay.
Did you?
Yeah.
Okay.
I
Cool.
just don't know what to do about the
It's so confusing.
first one. Just in general, or about the ones that we got wrong?
No,
Because
like the ones that we were having a hard time. It's just like it's like crazy.
yeah,
Yeah, I really don't understand what they're trying to say.
like the first and third one.
Yeah.
Weird.
Who knows? Anyway, I guess we'll move on to number 2 and try not to worry about it.
Yeah, that's probably fine.
Okay.
What's the growth and decay transformation?
You know, I don't know. Oh, I know. So, all right. So you know how an exponential function always grows? That's a growth.
Mhm.
And then when it's negative, it like, I guess it still grows, I guess, but it kind of just does this. And so I guess it's kind of like a decay, I think. I think that's it. And also, I think a log is a decay too. Okay. So I guess the first one I got that it was a decay. It's reflected across the x-axis. There's a stretch by 3. It's going to the right 2, and it's going up 1.
You said it's going left, right 2, up 1?
Yes.
Yeah. Okay, that's good. That's what I got. Right 2, up 1.
I might have said something differently, but I swear it's written down right. Is that what you got,
So,
Parker?
yeah, that's what I got too.
Okay.
When you graph that, I'm just trying to understand how that all works, because I looked at the answer key just to make sure I was doing everything right, and their graph looks different than I would have mine. So I just don't understand how they got from this point to there.
Where did you find the key? Like,
It says under group quiz. It's not really the group quiz. It's the answers for that question. There's only that one though that I'm seeing.
okay.
But I mean, to me, it looks like it was not even over 1 all the way, and not even up. It just looks weird to me.
Well, I think I said it earlier, but sorry, I heard your phone go off.
Yeah.
It was kind of loud. I think the 1 is like a horizontal asymptote, and so it can cross it, but usually I guess it's like kind of like a barrier, but it's not as strict as a vertical asymptote.
Okay. So how do you decide how to graph that, I guess, is what I'm trying to say.
That's a good question.
Because I wouldn't even know where to start with that, honestly.
well, it's reflected across the x-axis, so it's gonna go negatively, and that will turn it into a decay. And then you have the horizontal asymptote, and I'm not sure where the 2 comes into play. Honestly, I'm not very sure.
I guess those just give you kind of the shape of it, and then would you have to plug in X values, and then that's how you would solve for it?
I guess so, yeah. Just plug in y values, I guess. Right. So I already did the second one. Did you guys do the second one?
No, so I was just trying to figure out how to graph that first one, but I'll look at the second one.
Oh, you're okay.
So the second one would be a vertical stretch of 2, right? Right?
Yeah, it'll be stretched by 2.
Stretched by 2. Oh, it's on. Oh, yeah, come on. Sorry.
Reflected on the x-axis, right?
Yeah.
And then down 3, left 1.
Left 1.
Yeah.
Yeah.
I think like how the first one was a decay and it was reflected. I think it might be like kind of the opposite thing. Since log is usually a decayed function, then I think it might be a growth. Maybe. But I'm not entirely sure on that one. So.
Yeah, I don't know on that one.
Yeah. Okay. Shall we do the quiz and then get this over?
Yeah.
Okay. Are you guys there or?
It's a quiz.
Yeah.
I'm
Mm.
there. My internet's just slow, dumb. All right, I'm there. I'm here. Week 5, right?
Yep. I'm there.
I'm here.
Okay.
So logarithm. So the logarithm would be like a quantity that's like represented like it's like to the power, but like the base. You know what I mean? I mean, in the book, it's let me check the book. Hold on. Or in Google, it says a logarithm is a quantity representing the power to which a fixed number, in this case, it's the base, must be raised to produce a given number. Hello?
Sweet.
Yeah.
A logarithm is a quantity represented by a base.
Yeah. To produce base must be raised. A base must be raised to produce a given number.
Okay. A logarithm is a quantity represented by a base that must be raised to give a given number.
Yep.
Okay. Right. Next one.
It's just saying that they're the opposite of one another, right?
Not exactly. So remember, inverse functions are functions that where the coordinate x, y is just reversed. So the y becomes the x and the x becomes the y.
So would it be the same thing for logarithms and exponential functions?
Yeah. So it's just, I guess that logarithm x's equal exponential y's, or the other way around. I mean, is that right? I'm not sure.
I don't know.
What number are we on, sorry? Number 2, right?
Yeah, still on 2.
No.
I just don't know how to word that or say that.
Yeah, it's same.
I mean, so far I have logarithm x's equal exponential y's and vice versa.
Okay,
I don't know.
sounds good.
Yeah?
Yeah.
Yeah.
Okay. All right, number 3, find the inverse. Oh boy.
wants the inverse of 3. You guys get how to do this one?
Yeah.
I don't.
You want to explain it or do you want me to explain it? I don't mind. Well,
I think she froze. Maybe she's gone. I don't know.
oh yeah. Oh yeah, she did.
So, do you get how to do it?
Yeah, I get how to do it. So
Okay.
I set it up so 3 to the 2x plus 4, plus 3 equals y. So I subtracted the 3, right, to get it to the other side. So
Okay.
right now I have the equation 3 to the x plus 4 equals y minus 3. Catch me?
Okay, sorry.
So I erased the 3, right, from the equation. So then that
Okay.
gives me 3 raised to the 2x plus 4, right?
Yeah.
And then base it equals y minus 3. Okay? And then
Why would you would keep y in there, I guess? Oh yeah, you would. Okay, duh. Never mind.
So then what I did is, so I set it up like this. So I did 3 to the x plus 4, right?
Yeah.
Equals, and then I did like log. So I did 3 raised to the log of 3, and then y minus 3, parentheses.
3 raised
So then
to the
that way both the 3 coefficients, they cancel out, giving us like at the end 2x plus 4 equals the log of 3, parentheses, y minus 3.
Okay, sorry. Can you run through that one more time? I don't know. I had a
Yeah,
hard
yeah.
time understanding that.
Where do you want me to start off with? Like,
So I get how you have like 3 to 2x plus 4 equals y minus 3.
okay, yeah.
But then
Okay.
I guess I kind of got lost after that.
Okay, so I applied the exponent rule. So what I did is like 3. So there I get that right. Then what I did is on the right hand side I logged it to the 3. So I did 3 raised to the 2x plus 4, right?
Okay.
So equals 3 log of 3, and then open parentheses y minus 3. The reason I did that, so then that way the 3 coefficients, like number 3, how they're raised to 3 to the 2x plus 4 and 3 raised to the log of 3, those cancel out. Like, so basically, and then like that's why it brings down the equation, giving us 2x plus 4 equals the log of 3, open parentheses y minus 3.
Okay.
You get me so far?
Yeah. Yeah.
Okay. So then after that, what I did is I subtracted 4 from both sides. So the 2x plus 4, right, equals log of 3, open parentheses y minus 3. So I subtracted 4. So then that ended up giving me 2x equals the log of 3, open parentheses y minus 3, closing parentheses minus 4. You get me?
Yeah.
And then, so then you're left with 2x, right?
Mm-hmm.
2x equals log of 3, and then like open parentheses y minus 3, closing parentheses minus 4, and you divide by 2. So then that way at the end you're left with x equals log of 3, open parentheses y minus 3, minus 4, and then all of it over 2. And that's the inverse.
Okay.
Do you get it?
Yes. Yeah.
Yeah. You sure?
Yeah. I mean, it's a little complicated, but I mean, it makes sense.
Yeah. So did she come back on, or is she like?
I don't know. I think she just sent an email. Let's see what happened. Sorry, my laptop decided to crash.
Oh, that sucks. She's so goofy.
Okay, so
Who was supposed to submit the thing? Do you know?
I think she was going to.
Oh, okay. So
Let's see.
I'll teach her that. She said she got it. So I don't know.
Was that the last question, or did we have
There's
more?
one more question actually,
Dang.
which they shouldn't be that hard. I think, in my opinion.
Oh, there's one more question, but it's like 3 parts, right?
Yeah. But other than that, it should be fine.
Okay. I'm just trying to see what's going on.
Oh yeah.
Do you know how to do log of 4 in parentheses log of 3 log of 2 x?
Try. I mean, that one does seem a little bit.
I have no idea what that means.
All right, let's see. Let's see what we can do, man. So she said log of 4, and then log of 3.
Oh no, sorry. I'm just saying, like, for the next question.
Wait, what do you mean? I'm so confused now.
For like number 4, question number 4, part A.
Oh,
It's
like the
log of,
first one? Solve
yeah.
it. I don't know how that one will work actually.
Yeah, she still hasn't responded to me, so.
I can do B probably. B would, I mean, it's pretty easy.
Yeah, B and C, I think,
Yeah.
are reasonable. The other one, I have no idea.
B would be I mean, actually, C could be a little bit tricky though.
Yeah. Okay, let's see. She just emailed me back. Maybe we can rejoin that call. I'll just text.